Okay. Now I hope student then within one single problem, now I am explaining all the standard procedure and all the shortcut methods. Okay. If the Bode plots are in the options and the question is transfer function, then you don't touch pen on a paper. You can easily eliminate the options and you can get the one of the correct options with the following methods what we are doing. Either you go for slope of the line, or you go for change in slope, or you go for slopes around, or you go for starting magnitude, or you go for starting slope or ending slope. Now there are n number of possibilities to eliminate the options and choose the only one answer. Don't use step 1, step 2, step 3, all these things. But for the first time, for easy explanation I am giving. But in examination of GATE, you don't do like that. Okay, you can get the answer directly with the shortcut methods whatever we are approaching. Okay. Now the same question, actually I want to finish one more problem. Now this is the Bode magnitude plot. Am I right? This is the Bode magnitude plot. Now I want to try to draw the Bode phase plot also. What is the Bode phase plot? Phase angle of an open loop transfer function in terms of degrees. Phase angle of an open loop transfer function in terms of degrees versus frequency. Now same, write the frequencies in the ascending order. So this is the frequencies: 1 radians per second, √10 radians per second, and 10 radians per second. 1 radians per second, √10 radians per second, and 10 radians per second. Now see here. Now in 1 radians per second, this is minus 40 dB per decay. Minus 40 dB per decay is nothing but minus 20 means minus 90. Now minus 40 means again minus 180 degrees. Now this is minus 180 degrees. You know that minus 20 means minus 90 degrees, plus 20 means plus 90 degrees. Then how many number of minus 20s, how many number of minus plus 20s you can identify. Now this is minus 40 means minus 180 degrees. Next, 1 to √10. 1 to √10 is minus 80. Minus 80 is nothing but 4 into minus 20. 4 into minus 20 means 4 into minus 90. 4 into minus 90 means minus 360 degrees. But now where we are? We are at minus 180 degrees. So we are at minus 180 degrees. Then you go to minus 360 degrees. Now this is minus 270 and this is minus 360 degrees. And again you will spend some time there. Then √10 to 10. √10 to 10 minus 120. √10 to 10 minus 120 means 6 into minus 20. 6 into minus 20 means 6 into minus 90. 6 into minus 90 means minus 540 degrees. 6 into minus 90 is minus 540 means this is minus 360, minus 450, minus 540. Now this is minus 540 degrees. Next, √10 to 10. √10 to 10 is minus 540. Next, after 10 this is minus 100 degrees. Minus 100 degrees means 5 into minus 20. Minus 100 dB per decay means 5 into minus 20. 5 into minus 20 means 5 into minus 90 degrees. 5 into minus 90 is minus 450 degrees. Now this is minus 450, but we are at minus 540. Now this is minus 450 degrees. See here, this is minus 450 degrees. But if you remember or not, without drawing the Bode plot, now you have one shortcut procedure of finding final phase. How much is the final phase which we are already calculated for this particular problem? How much you are getting? You are getting minus 450 degrees. Will be same or not? But the problem here is this is an approximated phase plot. Why? Because this constant line indicates that the phase is independent of frequency. 1 or 0.5 or 0.6 or 0.2, 0.1, this is minus 180 degrees. No, it's not like that, because this is simple 0, 10 plus j omega, 1 plus j omega, 10 plus j omega plus j omega square. If you measure the phase of this transfer function, definitely the phase is depends upon frequency. Is it right or not? If you measure the phase of this transfer function, now because simple poles and simple zeros are available, you already know that the phase should be completely independent only the transfer functions consisting of whether system gain or poles at origin or zeros at origin. But whenever the combination of simple poles or simple zeros are coming, then definitely the phase is depends upon frequency. As frequencies changes, phase is also changes. So you should write like that, and after that the transfer function consisting of simple poles and simple zeros, and you should be draw a phase diagram like this. Take all these horizontal and vertical line center points. Take all these horizontal and vertical line center points, and by touching all these center points, draw a smooth curve. So what is the meaning of that? As frequencies changes, phase is changes. At one particular frequency, minus 180, minus 90, minus 360, minus 450, like that. So this is the phase plot. This is the Bode phase plot. Now for a given transfer function, okay. But the examination question and everything is on Bode magnitude plot. But don't worry, the Bode phase plot is also important for doing the one more topic in our subject. Now for explanation of that topic, I am using the Bode phase plot. Therefore, the students, for every Bode magnitude plot, you must and should try to draw the Bode phase plot. That is exercise for you. Now there is a Bode plot, and bottom of that you should be draw the Bode phase plot. Okay, such that you can have a good practice, and that topic is also very easy to understand if you understand the phase diagram of the Bode plot. Okay, now note on this. Okay, so this is the way to draw the Bode magnitude plot of any given transfer function, and this is the way to draw the Bode phase plot of any given transfer function. I hope there is no need to solve a number of problems, because within one problem I can tell you everything. If you try to understand the first problem, again go through that and see whatever I am saying, then you can solve a number of problems. Okay, without drawing the Bode plot also you can use it. Okay, now anyway, now we'll go for the next problem. This is the next problem. G of S, which is equal to right. Now this is the transfer function. Now use your shortcut method to try to draw the Bode plot first. Now what is the step 1? Find gain and corner frequencies. I am giving one shortcut method to you for finding the gain. What is the gain? Numerator constants by denominator constant is the system gain. 40 into 16 by 2 into 8 into 32. 16 cancel. Now 5 by 4 is the system gain, and this is the simple pole or simple zeros. It should be the corner frequencies. Now the zero, a pole itself is the corner frequency. 2 radians per second, 8 radians per second, and this is 32 radians per second. Now s square plus s plus 16. Omega n square is 16 and omega n is root 16 means 4 radians per second is the corner frequency. Right? Now this is the system gain and the corner frequencies are available. Now where we want to start the Bode plot, starting magnitude in terms of dB. The starting magnitude in terms of dB, which is nothing but 20 log k base 10 plus or minus, and some second portion is available, but no zeros at origin, no poles at origin. If there is no poles at origin or no zeros at origin, there is no second term, just 20 log k, which is nothing but k is 20 log k is 5 by 4 base 10. Now this is nothing but 1.93 and approximately 2 dB. Okay. Now this is the starting magnitude. Then you can easily draw the Bode plot without doing anything. Write the corner frequencies in the ascending order. Now the Bode plot, the magnitude of the open loop transfer function in terms of dB versus frequency. Now the magnitude of the open loop transfer function in terms of dB versus frequencies. Write the corner frequencies in the ascending order. 2 radians per second, 4 radians per second, 8 radians per second, 16 radians per second, 32 radians per second. Now the starting magnitude is 1.93. Therefore this is 1.93 dB. No pole at origin, no zero at origin. Starting slope is 0 dB per decay. Bode plot starts with a slope of 0 dB per decay. Now this 0 dB per decay is up to the first corner frequency. The first corner frequency is 2 radians per second. Now the first corner frequency is 2 radians per second. Now at 2 radians per second, one simple pole produces slope of how much? One simple pole produces slope of minus 20. One simple pole produces slope of minus 20 dB per decay. Minus 20 dB per decay. One simple pole, because minus 20 and plus 0 is minus 20. Now this is up to the next corner frequency. The next corner frequency is 4 radians per second. The next corner frequency is 4 radians per second. Now at 4 radians per second, then two simple zeros. At 4 radians per second, there are two simple zeros or two finite zeros. Two finite zeros or two simple zeros produce a slope of 2 into plus 20 is nothing but plus 40. Plus 40 is added to this. Plus 40 minus 20. How much? Plus 20. Now this is plus 20 dB per decay. Now this is up to the next corner frequency. 8 radians per second. Now at 8 radians per second, again you go to at 8 radians per second, again one simple pole. One simple pole produces a slope of minus 20 plus 20. Now how much? 0 dB per decay. 0 dB per decay. Now this is up to the next corner frequency. Because corner frequency is the frequency, the slope changes from one level to another level. Now again, this is 2, 4, 8, no 16. This is directly 32. Now 32 radians per second. Now at 32 radians per second, one simple pole produces a slope of minus 20, 0. Now minus 20 added to 0. Now the slope is minus 20 dB per decay. Now this is 0 dB per decay. And this is minus 20 dB per decay. Now this is the Bode plot. Now the students are having a question that, sir, this Bode plot is a correct Bode plot or not? How I can recognize, how I can know that? N number of shortcut methods to you, and very simple shortcut method. Now first you identify the final slope. What is the final slope? How many poles? 3 poles. How many zeros? 2 zeros. 3 minus 2 multiplied with minus 20 dB per decay. Now this is final slope. Now which is nothing but minus 20 dB per decay is the final slope. How much you are getting while you are drawing the Bode plot will be the same or not? Okay. Now such that you can easily get the answer. Okay. Even you have checked slope of the line as 2 to 4 is minus 20 I can get. Now you can get a same or not, you can have a shortcut method. And change in slope is correct or not, you can have a shortcut method. And slopes around is also you can have a shortcut method. Apply all these things, this is correct or not also you can easily get. Okay. Don't draw this plot. Already the plot is available in the options. Then you can pick up which one is correct and you can eliminate which one is wrong. Okay. Note on this. Okay. So you can easily identify any plot, the same procedure. Now here he is giving the transfer function. Sorry, he is giving the Bode plot. Now in the question he is already given the Bode plot. Now this is the Bode plot and this is the given Bode plot and you want to find the trans function. This is called as, now what the previous problem? He is giving trans function, we want to draw the Bode plot. Now he is giving the Bode plot, now you want to find the trans function, inverse Bode plot. Okay. Now reverse operation. Once if you understand one operation and automatically you can get the reverse diagram is also very easy. Okay. Now these are the corner frequencies in the ascending order. This is omega C1. This is omega C2. You know that the corner frequencies and time constants are always inversely proportional. Therefore, what is T1? T1, which is nothing but 1 by omega C1. What is T2? T2, which is nothing but 1 by omega C2. So T1, which is nothing but 1 by omega C1, 1 by 1, which is equal to 1. T2, which is nothing but 1 by omega C2, 1 by 10, which is equal to 0.1. Now 1 by omega C1 and 1 by omega C2, this is T1 and this is T2. Now 1 radians per second and 10 radians per second. Now this is 1, this is 0.1. Now this is the time constant. Next, now you know one thing. What is the starting slope? who will give the starting slope? The starting slope is given by number of poles at origin, or the starting slope is given by number of zeros at origin. What is the starting slope? Minus 20 dB per decay, which means that one pole at origin is the starting slope. Am I right? Not. Now see the transfer function. G of s, which is equal to some system gain k. The starting slope is minus 20 dB per decay, one pole at origin. Next, minus 20 minus 20 minus 20 will become minus 20 minus 20 minus 20 will become minus 40. Now the students, you just try to understand at that particular corner frequency how much is the added value. Minus 20 will become minus 40 by adding. Minus 20 will become minus 40 by adding minus 20 or not? Minus 20 will become minus 40. So how much is adding at this particular corner frequency? Minus 20 dB per decay is added at this particular corner frequency, because corner frequency is the frequency where the slope is changing from one level to another level. So minus 20 will become minus 20. So the added value is minus 20. Who will give minus 20 at a corner frequency? I am using the word corner frequency. The purpose is at corner frequency only simple zero is existing. At corner frequency only finite zero is existing. Simple pole is existing. It is in the form of 1 plus st. So at this particular corner frequency, minus 20 is produced by one simple pole. One simple pole means denominator 1 plus st. Now this is omega c1, this is t1. 1 plus st1. Next again, minus 40 minus 40 minus 40 will be converted to minus 60. Minus 40 will become minus 60. How much is added? Minus 40 will become minus 60. Then how much is added? Added is minus 40 will become minus 60, means the added value is minus 20. Am I right? Minus 40 will become minus 60 by adding minus 20 dB per decay. Now who will give minus 20 dB per decay at a corner frequency? Now minus 20 dB per decay at a corner frequency is minus 20 dB per decay at a corner frequency is again one simple pole. So 1 plus s t2 and system gain k. Now how to find the system gain k? Now you know the starting magnitude. What is starting magnitude? The starting magnitude in terms of dB is now 20 log k base 10. Now poles at origin, therefore minus how many poles? One pole at origin, 1 into 20 log omega base 10. But in the question the starting magnitude is already given. Minus 40 is given, which is nothing but 20 log k base 10 minus omega, the least corner frequency. What is the least corner frequency here? 1. Therefore 1 into 20, the least corner frequency is 1. So this is 0. Therefore which is nothing but minus 40, which is equal to 20 log k base 10. Therefore log k base 10, which is equal to 40 by 20, which is equal to minus 2. Therefore k equal to 10 power minus 2, which is 0.01. Now system gain k equal to 10 power minus 2, which is nothing but, now see here, what is the transfer function finally? Now 10 power minus 2 by s into 1 plus st1, 1 into s by 1 plus st2, t2 is 0.1 into s. Sir, is this one is correct or not? The students are having a doubt. If this one is correct or not, you can easily identify final slope, find final slope. What is the final slope? From the transfer function, final slope is 3 poles, no 0, multiplied with minus 20. How much? 3 into minus 20, minus 60 dB per decay is the final slope. How much you are getting? In the Bode plot is also minus 60, and you are finding the transfer function. This is also minus 60. Okay, note down this. Okay, is it okay or not? Then in the same problem, I just do a small change. Tell me then what should be the changes in the transfer function. Now if I take minus 20 dB per decay here, everything will be same. Current frequencies I am not disturbing. Starting slope, starting magnitude, everything will be same. Then now see here, now we'll start again. Now minus 20 dB per decay is the starting slope, therefore one pole at origin. Now minus 20 will become minus 40, therefore the added value is minus 20. At a corner frequency, this minus 20 is because of one simple pole. So minus 20 dB per decay at a corner frequency is because of one simple pole. Now minus 40 dB per decay will become minus 40 dB per decay will become minus 20, means how much is added? Now minus 40 will become minus 20 by adding plus 20. Minus 40 will become minus 20 by adding plus 20. Now tell me who will use plus 20 at a corner frequency. Now the plus 20 at a corner frequency is given by a simple 0 or not? Yes, therefore this is nothing but simple 0, 1 plus s, that here simple 0, 1 plus st2. Now k is 10 power minus 2, s into 1 plus s t1, t1 is 1. Now this is 1 plus s t2, t2 is 0.1, 0.1 into s. Now again, that is correct or not? How we can verify? Final slope. Now 2 poles. How many zeros? Now there is 1 0. 2 minus 1 multiplied with minus 20. Therefore, minus 20 dB per decay is the final slope. Is matching or not? Like that, the small change then which results the transfer function is also changes. And one more thing also. Now in the options, maybe the answer is not in this form, because this is which form? Time constant form. 1 plus st1, 1 plus st1, time constant form. But all the options may be in the pole 0 form. According to that, you do a small change. What is a small change? Now this is the transfer function. Now I want in a pole 0 form, take all constants as a common, 10 power minus 2, and this 0.1 if you take it as a common, now which is nothing but s plus 10 by, now this is s into s plus 1. Now this is the pole 0 form. Now the options may be in the pole 0 form. 10 power minus 2 into 10 power minus 1. Now it may be 10 power minus 5. Sorry, 10 power minus 3. Now this is nothing but 10 power minus 3 into s plus 10 by s into s plus 1. This is the transfer function in pole 0 form. This is the transfer function in pole 0 form, and this is the transfer function in time constant form. This is the transfer function in time constant form. This is the transfer function in time constant form, and this is the trans function in pole 0 form. Okay, now take down these two examples of the small change where the changes will be taking place. Okay, now you can solve n number of problems. Should be the same procedure. Now this is now this is the given Bode plot. Now this is the given Bode plot. Now you want to find the transfer function. Now first write the corner frequencies. Now these are the corner frequencies is already available and into time constant form. This is omega C1. This is omega C2. This is omega C3. Time constant and corner frequency is inversely proportional. Now T1, which is nothing but 1 by omega C1. T2, which is equal to 1 by omega C2 is 0.1. T3, which is equal to 1 by omega C3 is 0.01. This is the corner frequencies and time constant which is inversely proportional. Now, some constant, some system gain K. Now, what is the starting slope? The starting slope is a constant line is nothing but the starting slope is 0 dB per decay. Now, what is it indicates? The starting slope is 0 dB per decay, which means that no pole at origin, no 0 at origin, no S, no 1 by S, no S power n, no 1 by S power n. Next, this 0 dB per decay, 0 dB per decay will become plus 20. Am I right? This 0 will become plus 20. Means how much is added? The added value is plus 20. 0 will become plus 20. Now this 0 will become plus 20. Means how much is added? Plus 20 is added. Who will give plus 20 at a corner frequency? One simple 0. 1 plus ST1. One simple 0. Next, plus 20 plus 20 plus 20 will become 0 dB per decay. Plus 20 will become 0 dB per decay. Plus 20 will become 0 dB per decay, which means how much is added? The added value is minus 20. Now plus 20 will become 0 by adding minus 20. Now who will give minus 20 at a corner frequency? Now the minus 20 dB per decay at a corner frequency is given by one simple pole. Now minus 20 at a corner frequency is one simple pole or one finite pole, 1 plus ST2. Next, this 0 dB per decay will become minus 20. Now this 0 dB per decay will become minus 20. Now by adding minus 20. Now who will give minus 20 at a corner frequency? The minus 20 at a corner frequency is given by one simple pole, 1 plus ST3. Therefore, now the transfer function is K into 1 plus ST1 by 1 plus ST2, 0.1 into S, 1 plus ST3, 0.01 into S. Now what is the system gain K? Now starting magnitude is 20 log K base 10, but there is no poles at origin, no zeros at origin. There is no second term. Directly Now the starting magnitude is already given 20, which is equal to 20 log k base 10, which is equal to 20 cancel, 1 equal to log k base 10, now which is equal to k, which is equal to 10 power 1, which is equal to 10. Therefore, now the system gain k, which is equal to 10. 1 plus st1, 1 plus st2, 1 plus st3. Now this is the time constant form. If you take t1, t2, t3 as a common, you can convert it into pole zero form. Okay. Now the same procedure, and you should be identify where we have to start. Now you can easily get the answer. There is no need of doing all these things. Okay. Options are available. Trans function is available. See, you in the examination, if you don't do like that, all these 4 options are available now. Transfer function. So final slope, matching or not, or slope of the line between 2 corner frequencies, you know how to get the answer directly. So like that you can apply it and you can get the answer or not. Okay, just take down this. Clear or not? Now, these are the corner frequencies. This is omega C1, this is omega C2. Now, these are the corner frequencies, and the corner frequencies and time constant is inversely proportional. Now, T1, which is equal to 0.1, and T2, which is equal to 0.01. Now, G of S, which is equal to system gain K. Now plus 20 dB per decay. The starting slope is plus 20 dB per decay, which means that 10 at origin. Now 20 dB per decay. Now see here. Now the 20 dB per decay will become minus 20. 20 will become minus 20 means how much is added? Now we have to add minus 40. Who will produce minus 40 at a corner frequency? Who will produce minus 40 at a corner frequency? The minus means simple poles, but minus 40 means 2 simple poles. So at this particular corner frequency, there are 2 simple poles, which means that 1 plus st1 whole square. Now minus 20 minus 20 minus 20 will become 0 dB per decay. Minus 20 will become 0 dB per decay by adding plus 20. Minus 20 will become 0 dB per decay by adding plus 20. Who will use plus 20? The plus 20 is because of one simple 0, 1 plus st2. Now, starting magnitude. Now the starting magnitude, which is equal to 40, equal to 20 log k. So this is 2 equal to log k base 10, k equal to 10 power 2, 10 power 2, which is equal to 100. Now this is 100. Now which is equal to 100 into S into 1 plus 0.01 into S by 1 plus 0.1 into S whole square. Is this one is correct or not? How you can verify? You can verify easily because we have a final slope. So there are 2 poles and 2 zeros because this is ideal transfer function. If it is the ideal transfer function, The number of poles and number of zeros are same. Therefore, final slope is 0 dB per decay, and how much you are getting is 0 dB per decay. Am I not? The final slope a constant line. This is nothing but a 0 dB per decay is the final slope. Is matching or not? Yes. So like that you can easily get the answer. Okay. Now if you add minus 60 or minus 40 at a one particular corner frequency, which means that it is a simple poles or simple zeros of 3 simple zeros or 3 simple poles or 2 simple zeros, like that. Okay. Note on this. Now see, now this is the given body plate. Right? Now this is the given body plate. Now the students, you see here, the problem here is, now he is not giving the slope of the line. If the slope of the line is given, you can easily find. But in this question, the slope of the line is not given. Even if the slope of the line is not given, we can able to find the slope. Now first find the slope of this line. What is the slope of this line? Slope is change in y-axis by change in x-axis. This is m2. This is m1. Now this is omega 2. This is omega 1. What is the slope of the line? The slope of this line is change in y-axis m2 minus m1 by log, because this is logarithmic scale, log omega 2 minus log omega 1, change in slope. Now which is nothing but 140 minus 20, 140 minus 20 by log 100 minus log 0.1. Now which is 140 minus 20 is 120 by log 100 minus log 100 base 10 is 2. Now this is, this is log 10 omega 2. So this is 1 minus of log 0.1 is nothing but log 0.1 is -1. So 120 by 2, which is equal to plus 60 dB per decade. Now this slope of this line is nothing but plus 60 per decade. This is the way you can calculate the slope of the line.